Okay, Hussein. So in the last session, we had discussed about the uh, routing has been done and the switching concept. We already discussed what is the switch, how switch works, and how it maintain the MAC address table. Okay. So after that, we have a one more concept related to the switching only, that is the VLAN. And after that, we have inter-VLAN also. So that tonight we'll configure this both the things. Okay. So before going on to inter-VLAN, we need to understand about the VLANs. So we have a one. Let's suppose this is our our switch. Okay, this is our switch L2 switch. Okay, manageable L2 switch is there. The real time it will look like this. The physically devices looks like this. Okay, means there is a multiple interface where we can connect multiple end user device like printer, laptop, desktop. We can connect, right? In the same way, like you are having a power extension in your home, you can connect multiple mobile charger, multiple things you can connect, right? So the same way we can use. But why we are looking, why the VLAN is required? So let's suppose this, let's suppose this is the interface one, two, like that, and so on. It total 24 port is there. So in every port, there is one PC is connected. Okay, just assume multiple PCs are connected with the multiple ports. So this PC MAC address is A, IP address 10.0.0.1. This PC IP address is 10.2. This PC IP address is 10.3. This PC is IP address is like 10.4 and so on. Okay. So first time, as we know
Sir,
the
you
first,
sharing screen?
yeah,
No, sir. Like,
I said, no, I think you are connected with another device. So that is the reason it is not. I'm just telling you. Is it clear now?
yeah, now fine. Sir.
Okay, so this switch, so this switch, okay, switch is looks like the physically it looks like this. This is the L2 switch, L2 manageable switch. Okay. So in this switch, we have a multiple device connected, then and with the different IP with the different MAC address B, C, D, and E. Multiple MAC address means each device is having a specific MAC address. Okay. So let's suppose 10.1 wanted to speak with or establish the communication with 10.2. First time the packet will reach the switch. Switch will broadcast to all the switch, all the interface. Okay, all the interface. The connected device who is having a MAC address like how the packet will be like for this one. The source packet will be like this. So source IP, destination IP, source MAC, destination MAC, and one more thing like source MAC, destination source port, and destination port. These are the detail is available into every PC. So let's suppose 10.0.0.1 is the source IP. Destination is 10.0.0.2. Source MAC is A of this PC, B of this PC. But this this device don't know about the MAC address, right? The destination MAC address, the destination device MAC address. So it will broadcast like 255.255.255. Okay. So first time this will be the question mark. Okay. Like 255.255 and 255.255. Okay. Destination, the port number will be so source MAC. So source IP is the 10.1. This is the 10.2, and the source MAC is a and the destination MAC is a E. Source port can be anything, okay? Like for source port 10. I'm just assuming that source port is a 10, so destination port is a 20. Okay. The packet has generated, packet is reached to via this port number one, packet reached to the switch. Which will broadcast into the all the port. The device which is having a port number, the device which is having a 10.2 IP, the destination IP, the device will reply. Okay. Rest of the connected PC will just see the message and they will just drop the message. They will keep silent and they cannot reply. Okay, because this PC is looking for the 10.2 and I'm not 10.2. Okay, So in the same way, the switch will at the same time switch will maintain the MAC table. Okay, port number one I am having on PC, that is port number that is connected with the 0 by 0 or 0 by 1 interface. The MAC address is the A. The another 0 by 2, the MAC address is the B. Okay, like that it will do. So it is a broadcasting for all the it is broadcasting, right? And every connected PC getting impact. Correct.
Yes.
So to stop this, we have a one concept that is called VLAN. Okay. So VLAN will not for only to stop this broadcasting. So this is for the security purpose also we are using security like security like the security like let's suppose we have a multiple group of user in the office like management, finance, account, sales, IT, many things are there, right? So we can
Yes.
separate the users. Okay, like the finance management cannot communicate with the sales or account or this and other things. So every interface, every group of users will be individual at that time. Okay, let's
Okay.
suppose we have a 24 port, eight port we can keep in a single in a VLAN something in a VLAN like them. Rest will keep in some other way. Rest will keep in some other way. Okay, some other VLAN. Okay, another VLAN. Mean every eight port we are keeping eight port, four port, three port, two port based on the user. We can keep them in a particular VLAN. So the VLAN cannot establish the communication between with a different VLAN, even though they are
Okay.
having a same series of IP. All the interface means switch is having a 10.0.0.0/8 series IP only. But we are creating a VLAN is a logically boundary of of a switch. Okay, we are creating a logical boundary and we are keeping. So 10 dot this 888 will not communicate with others. Okay, means every VLAN is separate. Okay,
Yeah. Okay.
so how to create a VLAN? I'm just showing you. Later we can do the practice on this. Okay, so VLAN. Let's suppose I need to use one. I need to take the two pieces. This is the PC one and this is the PC two. Okay, so I'm keeping IP address as a 10.10.0.0.1, 10.0.0.2. No, not required. The gateway is not required. 10.1 is the IP. 10.2 IP of this one. Okay. 10.0.0.2. Okay, na?
Okay.
So now if you think from 10.1 to 10.2, ping 10.0.0.2, they can they can reach they can ping to each other, right?
Yes.
Correct? They are
Yes.
pinging each other. So now I will keep this both into the different VLANs. Okay, we'll see
Okay.
how are they what is the different now. Okay, so the command is enable configuration terminal. So we need to create a VLAN 10. Okay, name. Let's suppose I'm giving a sales. Name is not mandatory, but it is better for your identification of when you see the configuration. Okay,
Okay.
and after that one more VLAN 20 I'm creating. The name I'm keeping as the IP. Okay, so now I'm keeping interface fast Ethernet 0 by 1. This interface I'm keeping into the VLAN 10. This interface I'm keeping in VLAN 20. Okay,
Okay.
interface interface fast uh, 0 by 1 switch port mode access. Okay, switch port access VLAN 10. Okay, we call this particular 0 by 1 inside of port number 1. By default,
Yes.
in the morning I saw you that by default all the interface is part of VLAN 1, right? The native VLAN.
Yes. Yes,
Correct.
defined.
Interface pass Ethernet 0 by 2, switch port mode access, and the switch port access VLAN 20. Correct.
Yes, sir.
So VLAN bridge. Okay. So now this into 0 by 1 is a part of VLAN 10 and 0 by 2 is a part of VLAN 20. Okay. So now
Yes,
again, if you wanted to reach, it will not reach to it cannot ping to the 10.4. Okay.
yes.
Because there is a logical boundary. 10.1 cannot 10.1 is a part of this
One
partial
group.
0 by 1 is a different villain and the 0 by 2 is a different villain. Okay. So then they
Yes,
cannot reach together. So let's suppose if you wanted to establish the communication between them. Okay. So for that we are having a just a minute. Huh? So for that we have some concept that is called inter-Vlan routing. So we have a three-way. Okay, we have a three-way. By using that we can establish the communication between two different VLAN, or we can say the two different networks. Okay, so if you check, we have a 10 dot series and 20 dot series, 10 dot series and 20 dot series. This is the VLAN 10. Okay, this is a VLAN 20. The same
okay,
say VLAN 20 and VLAN 10. Okay, so what are the
okay,
interVLAN and what is the trunk port? Okay, that let me explain you first. Okay, in this lesson, we are going to take a look at routing between VLANs. Okay, when you want communication between different VLANs, we will need a device that can do routing. Okay, the routing can do by a L3 device or the multi-level device, having a which is having what? Which is having capability of learning a L3 packet, right? You would use an
yes,
external router, but it is also possible to use a multi-level switch. So we can use a router to establish the communication in between them, and also we can use a multi-layer switch. Multi-layer switch is nothing but that is a catalyst switch only, which is having a capability of performing a L2 and L3 services as well. Okay, so we have a
okay,
three method. That's the legacy method that we call as the legacy method. Okay. The second one is the router on stick, and third one is SBI. So SBI, we need one by one. We'll look. Okay. So let's suppose there is an inter-VLAN routing. These are the inter-VLAN routing method. Let's suppose you have a three VLANs into your switch. This is your switch, and you are having a three different VLANs. Okay. So
okay.
and three different pieces. Let's assume in this PC we have a VLAN. One PC is connected, second PC is connected, and third PC is connected. Okay.
Yes, yes, sir.
This is the part of VLAN 1. This is a part of VLAN 2. This piece is a part of, this piece is a
VLAN 2.
part of VLAN 2. This piece is a part of VLAN 3. Okay.
Yes, yes,
So just now we saw that different VLAN cannot communicate, right? To establish
yes,
the communication, we need a three physical interface. Means for every VLAN, we need to create what? We need to use one physical interface, right?
yes, sir.
That is a very old method to establish the communication between the two different VLANs, which is not in use nowadays. Okay, so we cannot do a practice for this inter-VLAN routing. We will just do a practice of VLAN, this router on a stick and the switch virtual interface. Okay, so first
Okay,
we'll talk about the router on a stick. Router on a stick is nothing but according to their physical structure, we are calling this as a router on a stick. Router is connected with the router is dependent with the single interface. So it just looks like a stick, right?
yes,
So that's a call we are calling as a router on a stick. Okay. So
okay,
how we can do? Let's suppose we have a one PC that is part of VLAN T, VLAN 10. One more PC we are having. Okay. That is a part of VLAN 20. One more PC we are having. That is a part of VLAN 30. Okay. Clear?
Yes, clear.
So for that, we have a one physical interface, let's suppose path is 0 by 1. So we need to create a sub interface. By using this single physical interface, we can create a multiple sub interface. Like how interface first connect 0 by 1 dot 1. Okay. So it will become
Okay.
like one sub interface. In the same way, we can use dot 2. It will become a second sub interface. In the same way, we can use a dot 3. Okay.
Okay.
And so on. We can create many sub interface. Okay, by using a single
Okay.
interface. And in every this interface, we can assign an IP. Let's
Okay.
suppose this is in 10 dot series, this is a 20 dot series, and this is a 30 dot series of IP. So we can assign an IP into each and every one. Okay, so
Okay.
they can establish the communication. But there is some disadvantage. What is the disadvantage? This communication is completely dependent on one single physical device. If this physical device goes down, the communication can be stopped for all. Okay.
Yes.
And one more thing, all the data of the multiple VLANs data is sending and receiving by the single VLAN
Oh,
only, single physical interface only, right? So
yes, sir.
there you will get some latency. Okay.
Yeah. Yeah.
So after that, we have a SBI that I will show you in the practical. So you'll need to know better way. Okay. So this is a
Okay, sir.
legacy method. Okay. This is a legacy method. For every VLAN, we need a separate physical interface. Okay, to assign an IP address and establish the communication. This is the legacy method of configuration, and we'll understand about the what. This is about router on a stick. So this is a router on a stick. First one 0 by 1 is a part of VLAN 10. The IP is a 10.1. The second one is a VLAN 20. The IP is a 20.1. The third one is first one 0 by 3 is a physical interface. Where we are having a two sub interface like first is 0 by 0 dot tail. We can use dot 2 dot 3 also. This is just a number. We cannot, there is no mandatory like if you are having a VLAN 10, so you can create a sub interface VLAN 10, not like that. Okay, you can give any number and assign an IP address. Okay.
Okay, sir.
Okay, so has let's suppose just discuss about this switch one. This is a switch one has two VLANs. So we have two different subnets, like two VLANs we are having and two different networks we are having, right?
Yes.
20.1 and the 10.1. If you want to communication between these VLANs, we'll have to use device that can do routing. So for that, if you wanted to study the communication in between, we required a one device, the routing device, that is the routing capability device, that is the router we are using. Okay. In this example, we'll use a router on the job. R1 will need access to both VLANs. R1 will R1 will need access to both VLANs. So we'll create 802.1 cube trunk between switch 1 and the router 1. Here is how to configure this. So 802.1 dot q 802.1 cube trunk. Trunk means this is the trunk. Trunk is the interface. Okay, let me show you this. Okay.
Okay.
This is we have two switches, and every in both the switches we have a multiple device, and the multiple device are every is a part of a multiple different VLANs. Like this is a VLAN 10. In the same switch, another switch also we have a VLAN 10. In the same series of IP, we have a 20. We have a 20 with the same series of IP. 20, 20, and 10. Okay.
Yes.
So by default, this 10 can communicate with the 10, but cannot communicate with the 20. By default, 20 can communicate with the 20, but by default 20 cannot communicate with the with 10. Okay, for that we need to use one interface. Okay, that interface should be a trunk mode. Rest of the interface we are keeping as a access mode, right? So this
Yes.
interface will keep as a trunk port. A trunk port is nothing but it is a port which is a part of uh, which is the which is the part or which is the responsible to carry a multiple different VLANs IP address. Multiple different multiple which is the responsible to carry multiple different VLANs data. Okay,
Yes.
without the trunk port, it will not work.
Okay.
That's, uh, sure. Okay. So
Okay, sir.
Without trunk port, it will not. So 802.1q is the trunk encapsulation. Number is given by the IETF. Okay, just a minute. Play this little bit. Just a minute. Huh?
Yes, sir.
The battery is getting down of the Bluetooth. Okay, so we saw the VLANs. We saw the. So let me delete this. This is not in. We clear about this, right?
Yes.
We'll go and we'll do this. Okay. Before that, let me complete this one first. Okay. So after that, switch configuration. We have a switch. Okay. We how to configure this. Okay. In the switch, what are the configuration that you need to do? In the router, what are the configuration that you need to do? Okay. So first, in the switch interface 0 by 3, 0 by 3. This is 0 by 3 which is connected to the router. Okay. Switch port trunk encapsulation dot one q. We are just telling this router interface is okay. This person 0 by 3 that you are the part you are the trunk mode. Okay. uh, we can there is no sequence of the command. We can directly do the interface personal 0 by 3, and we can run the second line third line command switch port mode trunk, and after that we can run this command switch port trunk encapsulation dot one q. Okay, and after that
Okay.
we can say this switch that to this into this we can say to this interface by using this command switch port trunk allowed. You
Okay.
can filter. Let's suppose you have thousands of villains, but if you don't want to allow the traffic of 30, 40, or some specific. Okay, in that case you can do you can clearly filter like 10, 20 only, or you can do switch port trunk allowed villain all means each and every villain can communicate. Okay,
Okay.
so this is about the switch side, the configuration you need to do. Another side, router configuration. Okay, router configuration. So what are the what in this is about the switch configuration. Now we need to do the configuration in the router side. So what we need to do? Interface personal 0 by 0 dot 10. Okay, dot 10. Okay, we can
Okay.
use a dot. So we are dot 10 is nothing but we are creating a sub interface of that 0 by 0 interface. Then we can use encapsulation dot one q. Okay, and we
Okay.
can you for which villain that villain 10 we need to tell them for which villain for villain 10. Okay, then we need to assign an IP address. IP address 192.168.10 dot 192.168.10 dot. What is the IP? Just a minute. 10 dot some. We need to change this IP. Okay, 10.1 or
Yeah.
10.2. I need to do. Okay,
Okay, sir. I will assume.
anything you can use. Okay, what is our in our case we can use here in the desktop only we are having 10.1, 10.2. You can give gateway the 10 dot 100 or 20 dot 100 anything you can. Okay,
Yeah. Yeah. Okay, sir.
like that. And after that we need to create second sub interface person 0 by 0 dot 20 encapsulation dot one q 20 IP address 192.168.20 dot 254. Okay, like this we need to do. So let me complete first this one. Then later we can discuss about the SVI. Okay, how SVI
Okay.
need to the what is SVI actually and how it works. Okay, so let me open this. Okay, so first of all we have a here just a minute, CLI. Okay, enable configuration terminal interface fast Ethernet interface range fast Ethernet 0 by 1 and 2 switch port mode access. Remember, I did not create it as of now any VLANs. Okay, I'll show you.
Yes.
So we'll brief. So VLAN brief. So all the port is a part of VLAN one only, right? And if
Yes.
if
Yes,
there
sir.
is no VLAN created, okay, we can create a VLAN configuration terminal VLAN 10. Okay, like that also we can create. If you don't have a VLAN, the switch will automatically create the VLAN also. Okay, how? Interface range fast Ethernet 0 by 1 to 2 switch port mode access VLAN 10. So what it is telling? Access VLAN does not exist. The VLAN 10, okay, is not exist. creating VLAN 10 means
Yes.
it will create automatically the VLAN. Okay, that the VLAN which you required. Okay, and
Okay.
after the interface range fast Ethernet 0 by 3 to 4 switch port mode access switch port
20.
access VLAN 20. Okay, done. So VLAN bridge 10 and 20 we call 0. Is it fine? Like
Yes.
we call this 0 1 and 2 inside of 10. We call 3 and 4 inside of 20 VLANs. Okay,
Yes. Yes.
that also we can do, and we can create in this switch. I'll show you. We can create a VLAN manually also. Enable configuration terminal interface range, not interface range. First, we need to create a VLAN. This is the second way when you want to create a VLAN by okay manually. So VLAN 10, okay, VLAN 10, and name if you want to allow name. Let's suppose sales I'm giving, okay, and we can create another VLAN 20 VLAN 20 name IT,
20.
okay, exit. Now to check, do so will and brief. Okay. So this is a part of we created a what 10 and 20 villains, but there is no interface has been called inside of this mode villain. So now we need to call interface range first Ethernet 0 by 1 to 2 switch port mode access and switch port access villain 10. Okay. Exit interface range first Ethernet 0 by 3 0 by first Ethernet 0 by 3 interface first Ethernet 0 by okay, interface range fascinate 0 by 3 to 4 and switch port access VLAN 20. Okay, so we have VLAN 10 and VLAN 20. Now we need to create this interface as a trunk interface. Port number 5 here also, there also. Okay, all the switches we have.
Okay.
So configuration terminal interface VLAN interface fascinate 0 by 5 switch port. Let me establish the communication first. Let me check that are they able to reach or not. Okay. 10.2
Okay.
here IP is a 10.2. Here IP is a 10.5. Means everywhere IP has been already assigned. I assigned the IP address. Okay. So let me
Okay.
first ping 10.0.0.5. Are they able to reach?
No.
No, right? They are not able to
Yes, sir.
ping, correct?
Yes.
So
Trunk
now
is
now if
not
you check
configured.
10.3. These both are in the part of this is a VLAN. Okay, 0 by 1 and 0 by 2. Okay. So IP interface bridge, not so IP. So VLAN bridge. So VLAN bridge. So VLAN 1 and 2. 1 and 2 is a part of VLAN 10. 3 and 4 is a part of 20. Okay.
20.
So 1 and 2. Okay, 1 and 2 is a part of VLAN. Okay. Okay. So at least 10 and 3 can reach, right? Because both are in the same connected with the same device, and the
Yes.
IP is not assigned here. 10.0.3.
Yeah.
Okay. So we don't need to okay
Gateway.
10.0.0. We can create as a one as a gateway. Gateway is not required when you want to communicate internally. So second one is here is also no IP 10.0.0.2 and 10.0.0.1.
1.
Okay. What is the IP which we assign here? 10 dot, okay, 10.3. Now you can ping 10.3. 10.3 can reach, right?
Yes.
Now let me ping the 10.5.
Hmm.
Check the 10.4 or 10.5 IP has been assigned or not. 10.4 need to assign that 10.0.0.4. 10.0.1. Here also we need to assign the IP address 10.0.0.5, 10.0.0.5, 10.0.0.1. So let me think from here again. No, they are not reaching, right?
Yes.
Why? Because this is a these are connected in a different switch. Okay.
Yes.
Now, if you take in the 20.2, 20.0.0.2, 20.0.0.1, and here 20.3. Here 10 we already assigned, right? Here 20 we need to assign 20.4, 20.0.0.4, 20.0.0. 20.0.0.5. Okay. Okay. So let me try from 20.2 to 20.5. Ping 20.0.0.3. They can reach 20.4. They cannot reach because both are in a different switch. So we need to what we need to do? We need to do trunk.
Trunk.
We need to create a
Trunk.
trunk port. Okay. So this is
Okay.
the part port. Okay. Here we need to do configuration terminal interface of fastnet 0/5 switch port mode trunk switch port trunk encapsulation switch port trunk and switch port trunk allowed all. Okay. Allowed VLAN all. Here. So once we created this side, VLAN is a trunk port of the fastnet 0/4. Okay. No need to configure again into this switch port. Why? Because this is in a this is a part of DTP. Okay, dynamic trunking protocol that will cover in upcoming class. By default, these switch ports are available into the access port and dynamic desirable. Desirable means if you call some, if you tell if this is a trunk and this is a dynamic desirable mode. Okay, so this will automatically negotiate with this port number 5, and it will become automatically port number trunk port. I'll show you. If you check so interface trunk, so interface trunk. Okay, so this will become automatically. It become port number 5 is automatically become right. How it
Yes.
become port number 5? Mode is the auto. Okay, and N means negotiation. Okay, negotiation.
Okay.
It is negotiated by the second one. Okay, the next hop interface. 802.1q is a encapsulation and native VLAN is a part of native VLAN 1. It is not a part of VLAN 20 or 10. It is a part of native VLAN. Okay,
Yes.
means by default here this is part of by default VLAN. Okay,
Okay.
got it? It will
Yes,
not
sir.
become a part of any particular VLAN. It is a part of multiple VLAN. Okay. So now try to ping 10.22. Now you can ping. We are
Yes.
able to reach, right?
Yes.
10.5 because trunk port we created. 10.4 we can reach. Now we can reach 20.2. Ping 20.0.0.2 and ping 20.0.0.4. We can reach, right? But
Yes, sir.
still 20 cannot communicate with the 10.2. Okay. Let me show you. Even it is connected with the same network, the same device also, they cannot reach. Ping 190 10.0.0.2. They cannot ping to each other. For that, we need to create once. We need to assign what we need to do
Uh,
here into this interface.
exactly.
We need to create a sub interface first. Enable configuration terminal. What are these are the configuration which we need to do here. First, in the switch, what will you do? In the switch, 0 by 3 switch port trunk encapsulation dot one to a switch port mode trunk allowed. Okay, that we need to do. So, into this, give it the router configuration. First, configure the switch interface configuration terminal interface Ethernet 0 by 6, right? Switch interface Ethernet 0 by 6 and switch port mode access switch port mode trunk switch port trunk encapsulation switch port mode trunk switch port trunk
Hello.
and yes,
No, sir. No,
audible.
sir. No, sir. I can.
Okay, switch port trunk encapsulation uh, switch port trunk allowed all. Okay, allowed VLAN all. Okay, no need to do much more things here. Encapsulation and all these things. What are the commands? So interface 0 by trunk, switch put allowed, switch put trunk encapsulation dot one. It is not working, so leave it. Into this interface, it is not accepting the command. Here, right. So into this interface, it is not working, so leave it. Okay, so now we need to create what? What we need to create? Here we need to create. We need to create in the router interface 0 by something whatever that we need to create encapsulation dot one cube and 10. Okay.
Okay.
So in the router side, we need to create sub interface. Interface first gigabit 0 by 0 dot 10, let's suppose. Okay. IP
Okay.
address. IP address is 192.168.10.1 and 255.255.255. Why 10.1? We have a 10 dot series IP, right? 10.0.0.1 and 255 dot. What is the subnet into this PC?
255.0.0.
255, right? Uh, and what is the subnet of this 20? That is the 20, 255 value. So guys, place rate, okay. So we need to change this at 10.0.0.1, 20.0.0.1. Okay, we need to keep like this. So 255.0.0.0 and no shutdown. Okay, so what it is telling? Configuration IP routing on a VLAN subinterface is only allowed if that subinterface is already configured as a part of an IEEE 802.1 queue, IT, dot 802.10, that is the VLAN ID, okay, and this is the number. So IEEE 802.1 queue, okay, or ISL VLAN. So what this is asking to, it should become a part of encapsulation.1 queue, okay. So what we'll do? Encapsulation.1 queue need to do. Just a minute. Encapsulation dot one queue for which VLAN? The VLAN number 10. Okay. Exit interface VLAN 20. Interface gigabit 0 by 0 and it will become part of what? 0 by 0 dot 20 I'm keeping. Okay. IP address 20.0.0 dot what? It will become part of 1 and 255.255 dot
No.
0 dot 0 dot 0 and no shutdown. Again, we got the same error. So it is asking encapsulation dot one queue and VLAN 20. VLAN dot one queue and it is asking for the VLAN 20. Okay. Nothing but that. So IP interface brief. So if you check, you'll get sub interface. So what is the sub interface? This is the base interface. 0 by 0 is our base interface, and we created two sub interfaces to this. Okay, 0 by 1 and 0 by 2 is there, which is the different one. Okay,
Okay.
so IP route. So there is no routing, so IP route. The routing is not configured. It should become right. So IP routing, configuration terminal, IP routing. And so, do so, do so IP route. System, do so IP interface brief. So 10 and 20, we assigned the IP also, right?
Yes.
Okay, interface gigabit 0 by 0 dot
Dot
10
10.
IP address 10.0.0.1 255.0.0.0 and no shutdown, right?
Yes.
Wait a minute. Here you need to do 20 for the second one. So IP interface brief. Still it is a down. Okay, okay. Down. Why it is? Okay, our base interface is still down, right? This base interface
Yes.
is down, right?
Yes, sir.
So we need to go for configuration terminal interface gigabit 0 by 0 and no shutdown. Once you did the no shutdown, this is by default is a shutdown mode. So if interface breaks, so now all is in up,
Yeah.
okay? And the
Yes, sir.
IP will routing will be there. So IP route. So routing is also came, right? Directly
Yes,
connected
sir.
and logic. So now we can start this, pinging into this. Okay. Let me ping from here 10.1, ping 10.0.0.0.1. You are able to reach our gateway. We can reach to 20.1 also, 20.0.0.1. We are able to reach
Yes.
10 and 20. Where it is 10 and 20 is in the router. So how the packet is, let's suppose 20.2 I'm pinging. Okay, 20.3. Let me ping 20.2. Request time of. Now they are starting this pinging, right?
Yes, sir.
20.3. Again, some packet will drop. Okay. So the established communication has been established between the 10 and 20 also, right?
Yes, sir.
I believe this is clear. So
Yes, clear.
I'm just going to stop the recording and after that we can go with the SVI. Okay. So let
Okay, sir.
me stop this recording.